Okay. Now this is a paper, part 2 paper. Right. Good. Now, Buddha, let's start. Okay. Now, see this part. The following questions are related to the second period elements of the periodic table. To answer the second periodic element mean, so this is what are the second periodic element from lithium to neon? Yeah, lithium to neon, right? Okay. Now from lithium to neon only you have to answer these questions. From lithium to neon. Lithium to neon. You have to answer this question using lithium to neon. Right. So using lithium to neon, please speak. The first one is the element having the highest second ionization energy. From lithium to neon, who is having the second ionization energy? Who is having the highest first ionization energy? Neon. Out of all these people, neon only having the first ionization energy. Highest second ionization energy being put, that should be, you know the ionization energy graph, it goes like this. Goes like this. So can you remember lithium is here? Lithium is here in the first ionization energy. So when it comes to second ionization energy, what will happen to lithium? From here, lithium will go here. Whatever the lithium here, now will go here. Then lithium only will have having the highest second ionization energy will be lithium. Is it clear?
Yes, sir.
Okay. Other part. Where are these people? Anit kollo set එක නැද්ද people.
Don't know, sir.
The elements showing a positive value for the electron gain energy. What are the elements will show the positive value of electron gain energy? Yesterday also we spoke. Tagala, tell me the people. Who are those people? Electron gain energy positive. Yes,
Beryllium and neon.
group 2, nitrogen and group 8. Group 2, nitrogen and group 8 people only will show positive electron gain. Normally electron gain is negative. Okay, electron gain is negative meaning is it's exothermic. If you want these points, you can write this. Normally negative mean it is exothermic. Normally electron gain is first electron gain is exothermic. But only these three people are endothermic people, positive people, group 2, nitrogen and 8. So the elements, group 2 element, you know, beryllium is here. Then nitrogen is here and neon also here. So you can write all these three things for the positive people. The element which shows the highest boiling point. Right. Who might show the highest boiling point out of these people? Lithium, beryllium, boron, carbon. Normally carbon, graphite, you know. Okay. Well, carbon only will show the highest boiling point. Okay. Graphite. The chemical formula of the compound formed by the element with the highest electronegative and lowest electronegativity. Highest electronegative element is in this group fluorine. Lowest electronegative person is lithium. Okay, so lithium fluoride. Okay. The element which forms electron deficient linear covalent compound. Electron deficient linear covalent compound is beryllium chloride. Okay, the element that is beryllium. Normally group 2 people. Beryllium. Okay, linear covalent, linear mean the example is BeCl2. Are these things clear? Any doubt in these five? Till will you? No, none, no. Yes, none is.
No, sir.
Others also speak. Only one person is speaking. Others also reply. Don't be silent. Go here, don't wait.
The fifth one, what is it?
Beryllium.
No, I didn't get the question.
They ask what is the electron deficient linear covalent compound. So electron deficient means they are not filling the octet. Now beryllium chloride, when you take beryllium is not filling the octet. So that's why beryllium is known as the electron deficient. So beryllium is here, chlorine is here. This is only beryllium chloride. This is only linear, this one. So this is shape is linear, but beryllium has only 2 electrons around it. So we are taking beryllium as electron deficient compound. Clear? Normally beryllium is electron deficient. Boron is electron deficient. Okay, beryllium, boron, both are electron deficient. Even BCl3. BCl3, that is also electron deficient. Electron deficient meaning is Putha, they don't have 8 electrons surrounding the any atom. Now around chlorine is filling the 8 electrons. But if you take beryllium is not filling the 8 electrons. That's why beryllium is known as the electron deficient compound. Right. Those things are okay. Now the other part. Now they have asked draw the most acceptable Lewis dot dash structure. Normally definite question for your system. So whenever they give a Lewis dot dash structure, what you have to do is right. First of all, say the valencies of this. Normally, mostly they give second period people. Mostly they give second period people only. See, all are belong to second period. Hydrogen is first period, but apart from that, all are second period. Mostly they give like that. Okay. Then you see the valencies. First of all, we'll see how many bonds are here. See how many oxygens are here? 3 oxygens. One oxygen is, we can see the valencies here. One oxygen is 2, then 3 oxygen means 6. Alright. Nitrogen valency is, 3. Nitrogen valency is, we can put 3. Nitrogen is 3. Okay. Then carbon, that is 4. Carbon's valency is 4. Alright. Then hydrogen, 3 hydrogens are there. Hydrogen is 3. 1 hydrogen is 1, 3 hydrogens are 3. Likewise, first of all, write the valencies, total valencies. Then add all the valency. 6, 3, 9, 4, 13, and 3, 16. Then total is 16. Then you have to see the number of bonds. Then see the number of bonds. So number of bonds will be, number of bonds will be 8. Okay. Number of bonds will be 8. Okay, number of bonds will be 8. So there will be 8 bonds here. Then put if there are 8 bonds in this, and then we can write like this. Let us see how many bonds are here. 1, 2, 3, 4, 5, 6, 7. Already 7 bonds are there. Then we are allowed to put how many more bonds? We are allowed to put only 1 more bond. We are allowed to put only 1 more bond for this structure. So we have to use only 1 more bond. So if you use 1 more bond, draw the most acceptable Lewis structure. So what you have to do here? If you want to put only 1 more bond, where can I put that double 1 more bond? I can put that 1 bond for oxygen. Because for 1 oxygen, I can put a double bond like this. Okay, I can put a double bond. So if I put a double bond for 1 oxygen, what will happen? After that, you have to see the charges. Because first of all, see how many bonds you can put. After changing the number of bonds, you have to see the charges. How to see the charges? You can see like this. See oxygen first. Oxygen valency is 2. They are bonded with 2 bonds, so charge is 0. Nitrogen's valency is 3, but this nitrogen is bonded with 1, 2, 3, 4 people. Therefore, their charge should be plus. Why plus? Because they have 1 more extra. Give me a minute. Okay. Now, Buddha, for nitrogen, you get a plus. Then see for this oxygen, normally oxygen valency is 2, but this oxygen is bonded with 1. So this oxygen should get a minus charge. This oxygen is okay, 2 bonds, carbon is 4 bonds, everything are fine. So when you get minus for this oxygen will have 6 electrons around that. This oxygen only 4 electrons. This oxygen 4 electrons here. Why every oxygen has 6 electrons? Then there is the final structure. Is it correct? Did you get this answer? Yes, the no, the what?
Yes, sir.
Sir.
Okay, good. Okay. This part is fine. And the next one. The most stable Lewis dot dash structure. They didn't ask you to draw resonance structures. They asked you to draw the most stable. If someone has put double bond for this oxygen and single bond for this oxygen, still fine. Huh? No problem. Other one is the most stable Lewis dot dash structure for the, if you have a doubt, then ask. Huh? After that, it will be a problem for you later part. So ask properly. Go and do the exams really well. The most stable Lewis dot dash structure for the molecules NO2F is given below. Draw another 2 Lewis dot dash structures or resonance structures. Mention the relative stability of them. Give reasons for the stability. Alright. Okay, another 2 Lewis dot dash structures they have asked you to draw. It means resonance structures. Okay. So when you are drawing resonance structures, Puta, remember, before drawing the resonance structures, may put this arrow mark. If you don't put this arrow mark, Puta, remember, you will lose marks. Although your resonance are correct, still they won't give marks for you. If you don't put this arrow mark. For resonance structures, this arrow mark is must. It should be double arrows, not one side arrow. Now you can see here, first of all, for this iron, this NO2F ion, first we'll see how many bonds are there. Already you can see there are 1, 2, 3 bonds only. But still we can confirm it. Nitrogen is what? 3. Oxygen 2. 1 oxygen is 2, 2 oxygens are 4. Fluorine is 1. Fluorine 1. Okay, so add all these things. 3, 4, 7, 1, 8. There are 8 here. So 3, 4, 1, 7, 8. No? 8 divided by 2 is how much? So number of bonds, how many bonds? Up to how many bonds I can put here? Up to 4 bonds. I can put up to 4 bonds, but they have put only 3 bonds here. Okay. This is wrong. Huh? This is supposed to be here. There should be a double bond. Right? The structure is wrong. What they have given is wrong because there's a plus charge on nitrogen. No, because there's a plus charge on nitrogen. Right. Now, Buddha, here, can you see, this structure is wrong here. Did you understand this structure is wrong? Yes, the no, the. Not the people. Reply, will you?
Yes.
I got wrong here. Did you understand? Earlier itself you understood or now only understood?
Earlier.
Very good. So there should be a double bond here. Why? Because there is a plus charge on nitrogen. Then definitely there should be a double bond here. They have asked another 3 more structures. So I can change the double bond site. I can put the double bond on this oxygen. Right? Because I can go only for 4 bonds. I can't go for 3 bonds or anything. I have to go with the 4 bonds. So I can put one like this. I'm not going to draw the extra electrons here. I just put the charge and charges only. Yeah. Okay, I'm not going to put the electrons. The electrons too. This fluorine will have 6 electrons. This oxygen will have 6 electrons. This is one structure. Okay. So another structure. Now, what is the other structure I can draw? Puta, can I put a double bond for fluorine? Only when you're drawing resonance structures, there are certain rules. Normally for hydrogen and fluorine, you can't put more than 1 bond. Remember that. And A points, hydrogen also maximum. These are very important points when you're drawing resonance structures. For hydrogen, maximum 1 bond. For fluorine, maximum 1 bond. You can't put more than 1 bond for fluorine. Right? And they are very important. Okay. Normally, fluorine you can't put more than 1 bond. Hydrogen you can put more than 1 bond. And second period people, this is another important point. Mark this. So in second period people, above again surrounding atoms, like surrounding, you can't go beyond 4 bonds. Okay, for an example, if you take nitrogen, you can go up to maximum 4 bonds. And එහෙම scene එකක් තියාවා. Remember that. Okay. Because they can't exceed more than 8 electrons. Second period people can't go beyond the octet. It means second period people can't fill more than 8 electrons. And they part take remember. Right. So I can put double bond here. Then what I can do, if I want to go for 4 bonds, I can do only one thing. I can put a triple bond for this oxygen. And for this oxygen, I can put only 1 bond. Okay. Then it will go for 5, ne? Yeah, ne?
Sir, now we should show it as a wrong structure, no? So we
Huh?
can put as fluorine. Double bond.
What?
We should show it as wrong structure, right?
But they didn't tell to show us wrong structure, no?
Like on another two.
No. You can put like this. Now, you can put only 1 more bond no here. Are? That's the issue now. If you put a double bond on fluorine, we can't, but you can put if you put double bond on fluorine, normally group 7 period, we don't put double bonds. But I can't put a triple bond on oxygen here. Why? Because I have to keep the total number of bonds equal. Now you can see there are 4 bonds. Now if I put a triple bond here for oxygen, what will happen? 3, 4, 5 bonds. We get 5 bonds. For nitrogen, we can't draw 5 bonds. Here we don't have a choice. We have to put fluorine double bond. Right? Normal conditions, but if you don't have any other thing, normally you don't go to put fluorine double bonds. But here, because we don't have any other option, we have to go for double bond for fluorine. A very unstable structure, but still have to go with it. The nitrogen will get a plus here. These both oxygen will get what? Minus. These both oxygen get minus. So this fluorine also 1, 2. This fluorine will get a plus. 1, 2, 3, 4, 5, 6. You have to go to plus for fluorine. Why? Normally fluorine valence is 1. Then this fluorine get a plus charge. So very unstable structure we are going to get here. Right? So we don't have any other option to draw this. Right? Now this is a very unstable structure here. So what you have to do here? Okay. Think you have to write here. This is stable. You can write this structure is stable. This structure you have to write. Okay, unstable because nitrogen and fluorine. Okay, both are having plus charge. You can remember now how to check the stability. If you are telling something as unstable, what are the 3 things we say normally? First, we have to check the adjacent charges. If the adjacent charges are having the same charge, they are unstable. Second, the most electronegative element will have a plus charge, mean they are unstable. Third, when the charge distribution is more, they are unstable. You can see every atom has a charge here. Then they have all 3 qualities, all 3 instability qualities, right? They have all 3 unstable qualities. Okay, adjacent atoms having the same charge, 1. Second, most electronegative element having a plus charge, second. Third one, I can tell the charge distribution is, right? It's more, right? Okay, so I think we have to come like this because we don't have any other option. Okay. That's it. Another, yeah. You can put a 2 plus on nitrogen. Yeah. You can try that method, but when we are going for 2 plus for nitrogen, 4 bonds won't be there. Only 3 bonds will be there. Okay. That issue also there. Okay. So number of bonds will change. Okay. Okay. Next. But for fluorine thing, when you are going to put the double bond, there is an electron to pair with this bond. But when you go to put hydrogen, now you can never put a double bond. Remember why? Because hydrogen there is only 1 electron. Then they don't have 2 electrons to share. Fluorine at least has 2 electrons, but they become very unstable. That is another thing. That's why they have asked to put the stability also. Okay, total number of bonds try to keep constant. By considering the Lewis dot dash structure given below, mention the following in the given table. Okay. Okay. We can see the Lewis structure here. And the atoms are numbered 1, 2, 3. But normally they will ask these questions in your term test. Right? So you should be able to draw these things. First one, VSCPR pairs around the atom. VSCPR pairs around the atom. Then O2. What is O2 here? VSCPR pairs mean what are the VSCPR pairs? Tell. What are the VSCPR pairs? Speak.
The bond pairs or lone pairs connecting.
Yeah. VSCPR pairs mean the sigma bonds and the lone pairs. Okay, VSCPR pairs mean sigma bonds and the lone pairs. These are the VSCPR pairs around the atom. So what are the VSCPR pairs around the atom here now? What are the now when you take O2 mean this one. So you can see 2 lone pairs, 2 sigma bonds. If there is a single bond, that's a sigma bond. So there are VSCPR pairs around the atom is 4. When you take the C3, is C3. So how many VSCPR units are there? 1, 2, 3. Only 3. Why? In a double bond, this is a double bond. In this double bond, one is a sigma, one is a pi. Then we are taking only sigma and the lone pairs for VSCPR units. Electron pair geometry around that. If the VSCPR unit is 4, this is tetrahedral. If the VSCPR unit is 3, it's a trigonal planar. Right. Shape around the atom. Here VSCPR units are 4, but lone 2 pairs, so shape is angular. Okay, that is angular. This one, same. This one, no additional lone pairs, so trigonal planar C3. Shape also trigonal planar. Hybridization of the atom. What are the things we check for hybridization? For hybridization also, we check VSCPR units. Okay, but we check VSCPR units. If VSCPR units are forming, hybridization is sp3. Okay, 1s and 3p's. Altogether 4. 4 will join together. Then VSCPR units are 3 mean you get sp2. Oxidation number, they have asked about the oxidation number. You can check the oxidation number. When you take this hydrogen and oxygen is more electronegative, Buddha. Therefore, what will happen? You can mark like this. Okay, this hydrogen get a +1. This oxygen get a -1. When you compare carbon and oxygen, is more electronegative. Oxygen get a -1, carbon get a +1. Okay. When you take this oxygen has double bonds. One bond is +1 and -1, two bonds mean plus -2 +2. So this oxygen get -2, this carbon get +2. This because of this carbon, there is no difference. If there is no difference, this also 0, this also 0. So you want to get the oxidation number of this oxygen. So see this oxidation state -2. Okay, this oxygen is -2. This C3 is +1 because this is -1, this is +1, this is -2, this is +2. +1 +2, you get +3 for this carbon. Is it clear how to see the oxidation number? So you get -2 and +3.
Can you explain that +3 again?
+3 1 you have to compare. This oxygen -1 means this carbon will get a
+1.
this carbon get +1. Because of this oxygen, one bond is -1, +1 -1. This oxygen is more electronegative, so this oxygen get, because of two bonds, -2. Then this carbon get
+2.
+2. Then what is the total oxidation state of this carbon?
+3.
+3. Right. Other thing. Now they have us mentioned the atomic or hybrid orbitals which participate for the formation of the following sigma bonds of the Lewis dot dash structure. Very simple. So always hydrogen mean what orbital? Atomic orbital or hybrid orbital? Takala speak. What is orbital involved for hydrogen? Can't hear what? Yeah?
Atomic orbit.
Very good. Atomic orbital. Because this is just S. This is what is hybridization of this one, sp3. You have to just write the hybridization. That's it. This is sp3. This carbon is sp2. This carbon is sp2. This oxygen, that also. You see, yeah? See the structure. Tell. What is this? sp? Tell the thing. sp what? Tell the answer, will you? What is this?
SP2.
I got sp2. You guys don't know how to see this? No? Speak, will you people?
Yes, sir.
You guys know. Others. All another.
Yes, sir.
Then this carbon sp. This carbon is sp2. This oxygen is sp3. And this hydrogen is S. So remember, Mehema, right? If there's only one thing, those are atomic orbital. If there's more than one thing connected, that is hybrid orbital. That's it. This is just S, no? Then atomic orbital. Then sp, S and P's are joining together. Then hybrid orbital. That's it. Clear how to see atomic orbital and hybrid orbital?
Yes, sir.
Yes, sir.
This is O2 mean sp3, right? Then O2 mean is sp3. C3 mean sp2. Okay. C3 mean we got sp2. C4 mean C4 is I guess sp2. Yeah, C4 is sp2. O5 is sp3. O7 is sp2. This is sp2. This is sp2. C4 is sp2. O6 is what? O6. O6 was sp2. Only for this one you have to write as AO. For all the other things you have to write as HO. HO in hybrid orbitals. Everything you have to write HO. All the other things are HO. Identify the atomic orbitals participate in the formation of the following pi bonds. Carefully see this. Pi bonds. Put us C3, these are the things which participated to form the sigma bonds. Alright? Now see C3. C3 is sp2. No? So when you know 1s is there, 3p's are there in an orbital. When this s and 2p's are joining to form the sigma bond mean Puta, who should form the pi bond? Whatever the p here. This only should form the pi bond. Clear?
Yes, sir.
Then which level this p is there? In which main energy level?
2.
Carbon is belong to second period, so this is 2p. C for O7. O7 also sp3, I guess. O7 is base O7 here. O7 is sp2. O7 sp2 who will join to form the pi bond? That also 2p. No? C4 also sp2, then D also 2p. O6 also sp2, then this also 2p. For everything we have right, what 2p. So what orbitals are these? Atomic orbital or hybrid orbital?
Hybrid.
Atomic orbital.
Atomic orbital. Remember these are alone 2p. Again, second energy level 1p orbital. Only 1p orbital. Only 1p orbital is involved. These are atomic orbital. Okay. Normally, the hybrid orbitals can't make pi bonds. Yesterday I told this. Only atomic orbitals can make pi bonds. Very important points. Are these things clear? People?
Yes, sir.
Yes, sir.
Then I will just do this and I will go. If you don't speak, I won't tell the very important points. Just imagine another thing like this. Normally, if you are making a mistake, you can make a mistake here. Something like this, oxygen, here sulfur. This oxygen and sulfur have a double bond. And this sulfur is connected to chlorine here. And another chlorine. And another fluorine. And okay, you think like this. Fluorine. Now this is also another fluorine. Okay. Okay. This is the thing. But can you tell this sulfur's hybridization, Taggala?
sp3 sp4
sp4 කියලා එකක් තියනවාද? අර after 3 piece D only will come back.
sp3d.
This is sp3d. What is sp3d now? This is the orbital which is involved to make what bond? What bond? Speak. Hello.
Sigma bond.
Sigma bond. Others don't know the answers. This sp3d is what? To form the sigma bond. Now can you see this oxygen? This oxygen 1 is a sigma bond. එතකොට sulfur's sp3d will involve to make this sigma bond. Can you see this one? This is a pi bond. So this one is a pi bond mean Puta. What is the orbital involved to make this pi bond? Pi bond is made between this oxygen and this sulfur. Okay. What is this oxygen's hybridization? sp2, right? Speak now. Speak. Now who is involved to make the pi bond of the oxygen and sulfur? Speak, speak.
Sulfur.
I told you these things. You guys have forgotten. For oxygen, who is making the pi? See, the oxygen sigma bond hybridization is sp2. It means this sp2 is making the sigma bond. Then who will involve to make the pi bond?
P orbital.
P orbital. Then 2p orbital will involve to make this pi bond. That is for oxygen. Then for sulfur. For oxygen 2p atomic orbital will in order to make the pi bond. For sulfur, see sulfur's hybridization. Sulfur's hybridization is sp3d. It means sp3d. These people are making the sigma bond mean. What is after D? After D also another 4Ds are there, no? Like this. Who will involve to make the pi bond? Whatever the D after this. What D? 3D.
3D.
Third energy level in 3D only will involve to make the pi bond. Is it clear, people, how to see the pi bond?
Yes, sir.
Yes, sir.
You forgotten? You have forgotten this. That's why telling me this paper class is very important. Because most of the time when you're doing papers on it, always set line. Don't forget, they are easy. So don't go to miss marks. All the things whatever involved make pi bonds are atomic orbitals, right? Very easily you can answer that part. Nice. Definitely you should write 3D and you can D killer don't write 3D. Third energy levels D people. Nice. Arrange the following into the increasing order of the properties given in the brackets. Reasons are not required killer, they have given. No need reasons, but we have to tell reasons. Already can you remember we compared this electronegativity of nitrogen. So if you want to compare the same type of electronegativity, tell me the order what are things. Same atoms electronegativity. If you have different atoms electronegativity bang, you can directly see from the Pauling scale. Again, you know from left to right electronegativity. Left to right electronegativity at 11, increase or decrease? Speak.
Increase.
Increase.
Speak. Left to right electronegativity will increase. When you are going from lithium to fluorine, electronegativity will increase. Why? Fluorine is the most electronegative element. Lithium is the least electronegative element. When you are going left to right, electronegativity will increase. Now nitrogen, now you have to compare the same atom. Then you compare the same atom. What's the order you have to check? First one, speak.
Hybridization.
Hybridization. Then
Charge.
Then
Oxidation number.
Oxidation state. Then
Atom attached.
Attachment. Okay, hybridization, charge, oxidation, and attachment. Okay. And this is the order. Now check the hybridization. Ammonia, nitrogen, what is the hybridization? You have to draw and see everything. So now you can write the hybridization. 3 hydrogens will join and 2 lone pairs will be there. So hybridization is sp3. What is this nitrogen hybridization? NH2 minus me. How you get NH2 minus? H2 minus is like this. The 2 hydrogens will be there. Then there should be a minus charge on nitrogen. Right? When you have a minus charge on nitrogen, nitrogen will feel like this. So still this nitrogen also sp3. This ammonium plus also sp3. So all are sp3. So no point of hybridization. Then check the charge. So I said positive charge people, electronegativity is more. Then negative charge people, electronegativity is less. So NH2 minus is the least among all. Okay. Ammonia is neutral. Then ammonia is second. Ammonium plus is positive. So ammonium plus is the most electronegative person. Okay. Is it clear? With the second quality, first quality is same because it's same in everyone. We have to check for the second quality. Everyone clear? Anyone has any doubt?
No.
Then clear?
Yes, sir.
Yes, sir.
Then this bond length, NO bond length, NOCl. How you draw NOCl? How you mark NOCl? Nitrogen. This side chlorine. This side oxygen. This is only NOCl. Right? NO2 minus me. This is how you draw NO2 minus. Nitrogen. This side there is oxygen. How you draw NO2 minus? This side oxygen. This side oxygen. This oxygen will get a double bond. This oxygen will get a minus charge. This is only NO2 minus. Okay? Na?
Yes, sir.
Then other one is NO plus. NO plus mean nitrogen and oxygen. See how many bonds are there in NO plus? nitrogen is 3, oxygen is 2, 3 and 2, 5. This plus 1 is plus 6. Then 6 bonds. 6 bond divided by 2 means 3 bonds. NO plus K again. There are how many bonds? There are 3 bonds. This oxygen will get a plus charge. That is unstable. You can do. Okay. So this is only NO plus. So when you check this, now whose bond length is shortest?
NO.
NO plus.
NO plus.
NO
Very good.
plus.
You can say triple bond. Then second,
NO2 minus.
no. It is NOCl only second. Why? Because these people will make resonance structures. Again, these people, this side you get a double bond, and this side you get a single bond. You can make a resonance structure. And by shifting the double bond, actually one person will have only how much? One permanent bond and appearing and displacing another bond. So this bond will be something like, it is equal to something like 1.5, not like a exact double bond. It will be like 1.5. Can you understand why it's 1.5?
Yes, sir.
Because at a time you have a bond here, other time the bond is not there. The bond is here. So one bond is distributing for both the things. So one is like 1.5 bond. Can understand for everyone?
Yes, sir.
So if they
Yes,
are making
sir.
resonance structures only, you have to do like this. If you can't make resonance structures, just leave it. So this one should be NO2 minus. NO plus is the shortest. So this is a triple bond. Here NO2 minus. And here NOCl. Right. Now decomposition temperature they have asked. For the decomposition temperature, you have to check with the ionic property. Whose ionic property is more? Magnesium, beryllium, calcium. Whose ionic property is more out of these three? Carbonate is same, anion is same. Last class also we discussed this Wednesday. Whose ionic property is more?
Calcium carbonate.
Calcium's ionic property is more. Why? Because when you're going down the group, polarizing power will reduce. When the polarizing power is reducing, the ionic character is increasing. So calcium carbonate. Okay, there's the most ionic compound. So most ionic compound, the decomposition temperature is highest. So calcium carbonate should be the highest. Least should be beryllium carbonate. Because beryllium carbonate ionic character is the least. So beryllium carbonate come first, then magnesium carbonate, then calcium carbonate. Okay, then calcium carbonate. So can you all understand these things? Everyone?
Yes, sir.
Right. Now, Buddha, you have a second structure design. Taggala. Type of interaction, the variation of the line spectrum of hydrogen. ML ඔක්කොම ABC කියලා දාලා ලොකු question එකක් දාලා තියෙනවා. අන්න ඒක try කරන්න. After that we'll discuss that. Okay. Start that. Second question.
In
Okay.
the second one, that bond, when seeing that bond, why did you put NOCl as larger than NO2 minus?
That's why I said NO2Cl එකේ NO bond. NO bond is a permanent double bond. Can we do a resonance structure between oxygen? Can't. But here between these two oxygen, one bond is shifting at a time here. So finally, if you do the resonant hybrid for this, for NO2 minus, one permanent bond is here for oxygen. Another bond is what? Appearing and displacing. Those type of bonds we have to mark in dotted line. Unpermanent bonds. And this minus charge also distributing at one time in oxygen, other time in this oxygen. So this minus charge also distributed to oxygen equally. So this oxygen get a minus half, this oxygen get a minus half. This is the resonant hybrid for this. You know the resonant hybrid, no?
Yes, sir.
Clear now? Why is it NOCl comes there?
Yes, sir.
Good. Try the second question. After that, I give around 10 15 minutes එක ටක් ගාලා try කරන්න ඊට පස්සේ we'll discuss that. Okay. Did you do? Done?
Sir,
Yeah.
5 minutes.
Okay. Now let's discuss. Right. To write the electronic configuration of chromium with the atomic number 24 and the number of unpaired electron of chromium atom. exists in the ground state. Then chromium in 24. They have given that also. So 1s2, 2s2, 2p6, then 3s2, 3p6, 3d, 4s. First 4s1, go as 4s1 and 3d 5. Okay, now my 4s2, 3d 4 key little come on 4s1, 3d 5 little change. Normally they will check this at this time. Normally first term they will check this special. Find the electronic configuration of chromium. Okay. Electronic configuration they are asking right here. So this should come here. Same question, no? Two times. Okay. Electronic configuration of chromium with atomic number 25 and the number of unpaired electrons of chromium atom exist in the ground state. Right. So unpaired electrons are 6. Okay, now chromium only out of all 3 elements, the maximum number of unpaired electrons. Okay, they got 6 unpaired electrons. Unpaired means this 3d5, all these 5 electrons will be there like this. Like as singly it will be there for all the 5 electrons like this. Okay, it will be singly, it will be there. OS1 means that also will be singly like this. So they have asked write the electronic configuration of chromium. Again the same question. Write the electronic configuration of +3 and +6 cations formed by chromium. So the +3 means the +3 same up to here it will come. This everything will come. Okay, this box I will put here. Now I'll put this box. This box means everything whatever there. For +3, what will happen? 3 electrons will be sent off. Then 1 from 4s1. Normally electron will start sending from 4s1. Then 4s1 again 1 will go. Then 3d5 again another 2 will go. Then here only 3d3 will be there. For the +3 state. For the +6 state, this 3d5 4s1, this entire set will go. That's why you have to write only this box. Whatever the box is. Up to 3b6. Only you should write it. But are these things correct?
Yes, sir.
Yes, sir.
Speak. Go.
Yes, sir.
I can't hear you. You're not speaking. I speak in on.
Yes,
So are
sir.
these things clear? Speak.
Yes, sir.
Okay. Now the other part. How many electrons present in the outermost shell of +3 ion of chromium? How many electrons? +3 ion of chromium. +3 outermost electron. Outermost shell. Outermost shell means 3D. 3 is third shell. Final shell. 3 shell. Third shell. How many electrons are present? From 3s to here to count. Here 2. Here 6. 2 and 6 mean 8. And this 3, 9. Okay, 8, sorry, 11. There are 11. Right. Name an anion of chromium having the oxidation state of +6. Write the IUPAC name of it. Anion of chromium. You got 2 anion of chromium which is in plus state. One is CrO2-. Okay, you can tell this one as, okay, what is this? How you name this? Chromate +6. Ion you should name it. Chromate 6. Okay, chromate, where within brackets you put 6, then ion. O Cr2 O7 2-. So you have right. Dichromate. Okay, dichromate 6 ion. Okay. Okay. Write the IUPAC name of the following compounds. NaClO. What is ClO mean?
Hypochlorite.
Very good. Hypochlorite. Then NaClO mean? Sodium hypochlorite. Okay. can be hypochlorite. Ide name ite. ITE. Sodium hypochlorite. You got four names. One
Sir,
is
that's
ClO minus.
ClO2 minus, no?
One is ClO minus. Other one ClO2 minus. Other one ClO3 minus. Other one ClO4 minus. Can you remember these names? So ClO2 minus and ClO2 minus we say chlorite. ClO3 minus we say chlorate. ClO minus now we say hypochlorite. It means ClO2 minus is chlorite. ClO minus will be hypochlorite. ClO4 minus will be what? Perchlorate. Okay, ClO4 minus will be perchlorate. So how should we write this name? Sodium hypochlorite. Sodium hypochlorite. Fe2H3, how will you write? Fe2H3 means ionic compound or covalent compound? Ionic. Now will you write iron? Fe nang iron. You have to write the oxidation state of iron. Iron, what is the oxidation state? 3. This is 3. Therefore, iron should be 3. Iron 3. Okay. Iron 3 sulfide. You should write. Iron 3 sulfide. Iron 3 sulfide. Are these things clear?
Yes, sir.
Yes, sir.
Good. You guys know how to write these properly, no?
Yes.
Good. Okay. They have asked fill in the table regarding the primary and secondary interaction. Hurry. Liquid bromine. They have asked the primary interaction and the secondary interaction. What is the primary interaction in liquid bromine? We have only 3 primary interactions. What are the 3 primary interactions?
Ionic, covalent, metal.
Ionic, covalent, and metallic. This is what?
Covalent.
Liquid covalent. Solid sodium, na?
Metallic.
Metallic. Hydrogen fluoride?
Covalent.
Covalent. Hydrogen fluoride is covalent. Okay. Hydrogen fluoride is not ionic, covalent. Between two non-metals, it's a covalent. Ice, na?
Covalent.
Yes, covalent. Paranitrophenol?
Don't know.
You guys don't know about paranitrophenol. I don't know why they have given paranitrophenol here. Paranitrophenol, na, I'll go and show. It's only paranitrophenol. When you see this itself, you're getting upset. No? This is not, you will learn this in unit. Okay, 7, 8, 9. Not now. Make a primary interaction with here, you can put that also covalent. Here, we didn't meet any ionic. Okay, all right. Secondary interaction. Liquid bromine. What is the secondary interaction you got? Liquid bromine, Br2. Br2, what is the secondary interaction of Br2? Br.
London dispersion.
Very good. London. The main secondary is London. Why? This is an unpolar molecule. Solid sodium. Secondary interaction, do they have?
No.
No. London you can put, because between every atom you got what? London dispersion force. London is there between everyone. For hydrogen fluoride means HF. What is the secondary interaction HF got?
London first.
London. Everything has London, but apart from that, what is the main thing here? HF.
Hydrogen bonding.
Hydrogen bonding.
You have hydrogen bonding. Very good. Ice.
Hydrogen bonding.
Ice mean what? Yeah, hydrogen bonding. Make a paranitrophenol.
Hydrogen bonding.
They get hydrogen bonding. You can see OH is there. All right. Good. Now they have given B part. The variation of the line spectrum of hydrogen with the wavelength is given below. So you can see A, you can see B, you can see C. They have asked, identify a series of lines A, B, C, mention the relevant regions of electromagnetic radiation in which of the series belongs. Putha, what should C belong? C is, see the number of lines. They got lots of lines. And who is it?
Partial.
Ah, C is partial. C is partial. See the number of lines they got. Number of lines. What should we see? People speak, will you?
Bama.
C, Barber.
C. Lyman.
C is Lyman. B is Barber. A is partial. Putha, when you think about the spectral line, can you remember in Lyman only we draw most of the, like we draw lots of lines, right? The Lyman. Can you remember for Lyman we draw lots of lines, lots of lines like this. Okay, so see the number of lines here. Here 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7. Here also 7. 1, 2, 3, 4. Okay. Normally, if there are more number of lines, we will draw Lyman. See the energy difference here. So this is like a very big energy difference. Normally, very big energy difference. Okay, everyone will get. Here from which side energy increases? Normally, how this energy, what level of the energy? Which side has energy increases? Or we have to think and see. If you have a
C
line
to
like
A.
this, if you have a line like this, where are the lines now? You have these lines at least. Think with this. Now you're drawing like this from here to here. Then from here to here. Then from here to here. Point. Now out of these three lines, which one is having more energy? If I put this one as 1, 2, 3. Which one is having more energy? 1, 2, or 3?
3.
Huh? Which one is having more energy? 1, right? Are an electron coming from here to here? Can an electron falling from this level to this level, this energy is more, or from here to here is more? Which one is more? Speak.
1.
1 is more. I have to fall from here to here. Then they will release more energy. The energy difference is what? From here to here. Now, if you draw lines like this, now you are drawing line, first line. This first line indicates this. Second line is what, Putha? When you're doing second line, you have to, there is a gap here. I think may gap. You can see here this gap. This gap, this gap. You can see this gap. And that gap only will come here. Okay. That gap means between this the gap. That's the energy difference of these two. Another one will be chuttak more. When the energy gap is increasing, what is happening to the energy? Reducing, right? From here to here, what's happening to energy? When you're going from here to here, energies, till energies reducing or increasing?
Decreasing.
Energy is decreasing. Okay, and remember when the gap is becoming more, energy is reducing. Got the point? So why we said this one as Lyman, so with the number of lines, because they got lots of lines. Because when you're going from a series, what will happen to the number of lines will start to reduce. Okay, so for an example, you say now this is Lyman killer, just take one killer coming for first level. When you're coming for second level, you will do only two things. See, one will reduce. When you're coming for the next one, you will do only one. So number of lines will reduce when you're going from this cone to this cone. All right. So they have asked, mention the values of NF and NI relevant to the line with the highest wavelength of each series of lines. Right? Okay.
Sir, then B is also Lyman.
No. B should be Balmer. Bth Lyman can't be. Okay. 1, 2, 3, 4, 5, 6, 7. Within 7, within 7, but here is supposed to be 6. Issue. නැත්නම් මෙතන තව එකක් extra one එන්න ඕනේ. හරි? Here 1 2 3 4 නේ වැදලා තියෙන්නේ මේකේ. මේකේ 1 2 3 4 5 6 7. මෙතන 5 වෙන්න ඕනේ, මෙතන 6 වෙන්න ඕනේ. ඒක ලොකුවට ඉතින් සීන් එකක් නෙමෙයි. May mention the values of NF and NI. NF mean N final. NI mean N initial. Relevant to the line with the highest wavelength of each series of lines. Now, if you are drawing like this, here how many lines are there? Like if you check this 1, 2, 3, 4, 5, 6, 7. There are 7 lines. 7 lines mean you should have 7 lines like this. What should be the end final? The highest wavelength should be for the shortest energy, no? Am I correct?
Yes, sir.
Highest energy should be the shortest wavelength. Then for each line, what should be the shortest wavelength? Whatever here. If there are 7, 1, 2, 3, 4, 5, 6, 7 mean from which one to which one should be the shortest? Shortest of this should be Gomat N2 to N1. If it is Lyman. Okay. N2 to N1. N initial should be 2, N final should be 1. Then if it is Balmer, for Balmer, N3 to N2. Then for Partian what? N4 to N3. Can I understand that point?
Yes, sir.
There you go. Okay. The shortest line only should have the highest wavelength. So if you are taking a Lyman series, the shortest wavelength is for 2 to 3. Balmer series again 3 to 2. Partian again 4 to 3. Everyone clear?
Yes, sir.
Then N final should be what?
Yes,
N
sir.
final mean wherever the electron is falling. Electron will fall to 1 now, right? Electron if it falling to 1 mean that is only N final from 2 to 1. Right. Good. Next. Explain reason to exist each series of lines of the emission spectrum of hydrogen separately. Because they emit from different wavelength. Okay? Because different electron has different energy. Therefore, they release different amount of energy. You have to tell. Excuse me. Right. May hurry. Because explain the reason to exist each series of lines of the emission, because different electrons exist in different level and it will fall for different levels. Therefore, it shows different emission spectrum. Right. Because everything won't go for the same level, because of certain energy level, hydrogen will go for different energy level. Therefore, it will fall into different levels. Okay. What are the colors of each lines PQRS? Putame BK. When they say still the colors of PQRS කියනකොටම definitely B is what? Balm කියලා double confirm. Because you see colors only in what? Only in what?
Balm.
Speak will Now what are the 4 colors in balm? What are the 4 colors you see in balm? Speak will I said no. What are the 4 colors you can see in balm?
Red, green, blue, violet.
Very good. Very good.
Blue, yellow,
Red.
orange.
No. Not everything. The main 4 colors. What are the main 4 colors? Red, blue, green, violet. Okay. What are the main 4 colors? Red, blue, green, violet. Remember. Normally remember VIBGYOR. No problem. Remember the VIBGYOR. Right. You have to recall your memories. Remember the VIBGYOR. Okay. When you remember the VIBGYOR, you remember. But you won't see all the colors here. Mainly there are 4 colors. Main 4 colors. This violet and red you have to select. VR. Other one. Okay. BY. By. Okay, these are the 4 colors. Okay. VR and BY. Blue, yellow. Blue and yellow go together almost. Blue, yellow and VR. So this goes in this order. So which one has more energy here? P only should have more energy. Why? When the gap is increasing, energy reducing. So P only should be violet. Q should be blue. R should be yellow. S should be red. Because red has the least energy. Violet has the most energy. Can remember these things? Can you remember people?
Yes.
For to explain this itself, it takes more amount of time, right? Next time you do like this. This Wednesday also we'll try to discuss. This Wednesday we are having energetics. Okay, so you can call your friends. They also can join the session. So the next Friday we will discuss the other part. Give me a minute. Now, these things are fine. Where was it? Fill in the blanks. Consider quantum number NL ML, which is used to describe the atomic orbitals. The medical fill කරන්නලු. So මේක 2p නේ atomic orbital. The main N is main energy level 2. L mean p na. That's that one, right? Here 4 2. Then what is this? 4 mean 4 energy level 4. L is 2 mean that is D, right? ML is minus 2 na. D how much? D which orbital? 4D. Putha, can't you tell? 1 2 3 4 5. So here 0, here minus 1, here minus 2. Then 4D. 1 kilo you can write, or 42 kilo you can write. 41. Here you can write. Okay. 3s na. N is 3. To get S 0. So ML also 0. Okay. Right. Are these things clear?
Yes, sir.
Quantum numbers can remember, no? Completely?
Yes, sir.
Calculate the energy of photon of red light having the wavelength of 700 nanometer. What is the formula you have to use here? Equal. Tell the formula.
Hc over lambda.
Equal Hc over lambda. Very good. Equals Hc over lambda. And you have to put this, and you have to put H as 6.626 into 10 to the minus 34. joule seconds. C is normally these people traveling in electromagnetic waves, they travel in speed of light, so 3 into 10 to the power 8. Lambda is 700 nanometers. You have to convert to meters, so 700 into values 700 into 10 to the power minus 9 kilo you should put. And if you simplify, you get the answer. Did you do this question? You get the answer? No?
No.
Oh, yes. But can do, no?
Yes.
It was say from this what you will get? What you will get from this? Energy of?
1 photon.
Very good. 1 photon. We will get energy of 1 photon. Then whatever the value you are getting from this, on the acre, they have asked energy supplied by 1 mole of photon. Then how to see 1 mole of photon? We'll say the answer what you got for this one is x here. That x you have multiplied by L, the Avogadro constant.
Avogadro.
If you multiply by the Avogadro, because 1 photon's energy is this much, mean 1 mole there are Avogadro number of photons, so you have to multiply by Avogadro. So then it's a calculation part you have to do. Can I understand these things, brother?
Yes, sir.
How much this session was useful out of 5? 5 out of? Rate everyone. Which useful the time you have spent in. Everyone rate name a time. Rate out of 5, how much it was useful? 5, 3.5, the 4, the 4.5, the 5, the 505. Rate the session. How much it was useful. Just put a chat together, rate it. Chat together, rate it. Your chat, your personal chat. Some already rated, Anit Katyat rated. And you got a redox question here, Netigat Karaganda. You'll get a question paper like this. After that, you get a redox. We definitely have rate. And after that, there is something related to parts per million, parts per trillion. Already I explained what is parts per million. And after that, some question related to ionization and energy link, they will give some questions. It has a small calculation part they will give like this. Okay, and some to explain about few properties. And remember their molecular shapes they will give. Okay, definitely they will give the molecular shapes. And definitely they will give this nuclear reactions. It was in the you will get. Right? So කරගන්න පුළුවන් බෑ නෙමෙයි. Already whatever we have done it right? Okay, then I think we'll wind up today's session. We'll meet on Wednesday. Till that, goodbye.